With traditional Ethernet switches, we can support a little over 4,000 VLAN. The spine switches allow any leaf switch to get to any other leaf switch in only a single hop. We just have to go through one spine switch because every leaf switch is connected to every spine switch. And the device that does our VXLAN encapsulation is called a Virtual Ethernet Module, or a VIM. And each VIM has an IP address. It could have more than one, but it's got at least one IP address that we're going to use to communicate over this routed network. And the IP address, it's assigned to a special interface called a VTEP, which stands for VXLAN Tunnel Endpoint. And each VTEP is associated with one or more VNIs. And VTEPs on different switches, they can temporarily bring up a tunnel and pass traffic between themselves. By the way, another benefit that VXLANs give us is that if we're sending traffic over a port channel where we've got multiple links making up a single logical link, instead of just using one link, the VXLAN switches know how to load balance that traffic across all of the different links in the port channel. That can dramatically reduce congestion in the data center. But an issue we have is, what do we do with traffic for which we don't know the destination? I mean, on a regular switched infrastructure, a switch that doesn't know how to get to a destination, it's going to send out an ARP broadcast perhaps. What about multicasts? What about unknown unicasts? What if we don't know where somebody lives? How do we get to them? Well, for that type of traffic, called BUM traffic for broadcast, unknown unicast, and multicast, we've got different approaches for handling that, but we're going to consider in this example using multicast. That's a very popular approach. What we can do is have these different VTEPs join a multicast group. Now, you might be wondering, do we have to have a multicast group for each VNI? And no, we don't. We can have multiple VNIs belonging to the same multicast group, because the VIMs themselves, they're going to look at that VNI identifier before sending the traffic out, and it can see, even though it received it over this multicast group, it's going to see that, oh yeah, this is destined for a different VNI. I don't send it out of this port. So it's totally fine to have multiple VNIs associated with the same multicast group. Now let's walk through an example of how this is going to work. And the table you see on screen, that table is being maintained by Leaf Switch 1, Leaf SW1. And what we want to do here is we want server 1 to communicate with server 2. How do we do this? Well, server 1 is going to send out an ARP broadcast because it knows it wants to get to 10.1.1.200, but it doesn't know the MAC address. So it sends out an ARP broadcast. And when that frame goes into Leaf Switch 1, it's going to make an entry in its table that says, hey, I just learned that the always MAC address lives off of port Ethernet 1/1. And that switch also has a mapping table that says VLAN 10, to which server 1 belongs, maps to VNI 100010. So now we have a VNI identifier, not just a VLAN identifier. And the way we're going to get to that is go out of Ethernet 1/1. Well, we just sent broadcast traffic into this Leaf Switch 1. What's it going to do with that? Well, for that BUM traffic, remember broadcast, unknown unicast, and multicast? We're going to send that out to a multicast group that our other switches joined. And Leaf Switch 3 sees that because it's a member of that multicast group. We're pretending that the group number is 239.1.1.10. When it gets that broadcast ARP sent via multicast, it's going to flood it out all of its other ports. So it's going to go down to server 2, and server 2 says, yep, that's me. And it says my MAC address is the all B's MAC address, and it goes back to Leaf Switch 3. And Switch 3 now knows that the 10.1.1.200 IP address with the all B's MAC address lives off of port Ethernet 1/1. So it's going to respond to the other VTEP and say, hey, if you want to get to the all B's MAC address, come to me. Come to 192.168.1.33. That's my VTEP IP address. And it sends that information over to Leaf Switch 1. And Leaf Switch 1 is going to make an entry in its table that says, if I want to get to the all B's MAC address, which lives in VNI 100010, I want to go to a VTEP IP address of 192.168.1.33. And it's going to send the result of the all B's MAC address down to server 1. So now when server 1 wants to communicate with server 2, it's going to send traffic to a destination IP address of 10.1.1.200, which by the way is in the same VLAN even though we're separated by a router. It's going to say I want to go to that IP address with the all B's MAC address, and Leaf Switch 1 is going to say, according to my table, the all B's MAC address is available via VTEP 192.168.1.33. So leaf switch 1 is going to form a VTEP tunnel with leaf switch 3. It's going to send that traffic over there, and leaf switch 3 is going to send it out to server 2. And that's a look at how VXLAN communication is going to be able to allow different devices that live on the same subnet, the same VLAN, to communicate with one another across a routed network. And it's very useful in a data center to have all those extra identifiers because, as we discussed, we could run out of VLANs, but we're probably not going to run out of VXLAN network identifiers.